All right. Hi, everyone. My name is Daniel. I'm on the protocol team at TFH. For those who don't know, TFH, or Tools for Humanity, is the first core contributor to the world ecosystem. So you can think of World App, World ID, World Chain, these sorts of things. And today we're going to go through some of the things that we've been working on that involve Noir, and really a big effort of ours to move a lot of the proving that we do to the client side, and how we explore bringing client-side proving to kind of, pushing it as hard as we can, all within, bringing like maximally privacy preservation within ZK context. So the first, if you're not familiar with World or WorldCoin, World Chain, succinctly put, it's the largest real human network. We basically use a bunch of sensor data, sophisticated sensors from the Orb. It's a hardware device that we manufacture, and a bunch of mathematics to prove that a given person is a unique person amongst the set of all people who have ever come and verified through this process. What this allows us to do is it enables us to essentially say who's a bot and who's a human, and this opens up a lot of really interesting use cases. With these two aspects, we're able to create a really rich network and ecosystem of applications, protocol mechanisms to really deliver an enhanced UX for real people alongside bots. For example, one of the things that we just launched on World Chain Sepolia was priority block space for humans. We're looking at gas subsidies for humans, because we can know that these users are real users and we can give them preferential treatment for a better experience both on and off chain. So I think it's valuable to go through kind of like end-to-end how the system works, how a user onboards to the system, and then how they actually use their World ID. So first things first, a user will download the World app, which will set up a semaphore key pair set. Semaphore is a protocol developed by the Privacy Scaling Exploration Group that's supported by the Ethereum Foundation, which essentially allows you to prove membership inside of a set, inside of a ZK context. So the way this actually works is the public key generated from this key pair set exists within a Merkle tree, where then the user can take an inclusion proof, proving inclusion of this identity in the set for a given root, and then prove this proof within a ZK context, alongside proving that they own the private key corresponding with this public key. And so users can say, without ever exposing who I am, even an identity within this set, to a verifier that I am actually in this set. So where this becomes really interesting is how we couple this with the Orb. The Orb is essentially the entry point for the proof of personhood credential that basically it's this hardware device that has a bunch of sensors on board. You can kind of think of it as like a really high-powered camera that takes a really high-resolution photo of your face, and in that photo, it's able to derive essentially the entropy in your eye. These values are translated into basically a byte array where it's compressed, a bunch of filters are applied to it, and it's translated into what we call the iris code. This is encrypted, and then it's sent off for a multi-party computation that verifies that this is a unique identity amongst all the identities that have ever signed up and gone through this verification process. There's a ton of technical docs. There's a paper we published on the MPC setup itself. So I'll kind of gloss over the details there and keep that high level, but feel free to come snag me after the talk, and I'm happy to send you all the references and documentation. It's actually a really cool setup if you haven't read into it. So just a quick review. A user will download the World app, generate a semaphore key pair set, go through the verification process, and then the public key with the corresponding private key, the public key will be inserted into a Merkle tree that exists on-chain on Ethereum mainnet. Then that root for the updated tree will be bridged to all of the corresponding chains where World ID exists, where then users, applications, both on and off chain, can use this root to create a World ID proof saying, I am a member in this set, I have verified, without ever having to say which member of the set you are, or exposing any sort of public data, private data about that person. Cool. So a brief look at the network today. Right now, we have 11 million unique humans that have signed up and actually gone through that verification process. There's 23 million users who have downloaded the app, have a semaphore key pair set, and have some degree of a credential, whether that be like a device uniqueness credential, the proof of personhood credential via the orb, and then we've cleared, at this point, over 267 million transactions facilitated via the World app. So super exciting about this growth, but there's a lot of scale to be had. And so we want to evaluate and look at what are some additional credentials that we can use and incorporate into the World ecosystem. And that brings us to things like a passport, a national ID, a driver's license, things that can be verifiably proven within a ZK context. Not only is this something that is more accessible to many people across the world, anyone who has an ID, if we have this credential set up, they can onboard. If they don't have access to, like the orb, for an example, they might be able to use their ID, like a passport. But also it includes some interesting metadata that a user can use within a ZK context and assert specific predicates over those data, to say like, I am from this country, I am Y years old, all without ever exposing any of that information to the verifier. But this comes with challenges. There's the question of like, how do you actually ensure that the ID that was used to verify that person is a legitimate ID and also corresponds with the person that's using it to sign up. This is like a challenging problem to solve. There's ways to solve it with varying degrees of trade-offs, complexity, and oftentimes people will default to the bad option, which is the simplest option, which is send all of the data to a centralized server where authenticity tests can be done. This is easy to implement. It's lightweight, but at the end of the day, it's zero privacy preservation, and it just does not clear the bar for what we feel digital credentials should have. So at the World Foundation, Tools for Humanity, and a bunch of the partners that we've continually collaborated on this effort, we think there's a better way. This is certainly not the end game and not something that we want to settle for. So the second option, if anybody could have seen where this is going, is using zero knowledge to verify that the data associated with the ID is signed by a valid government or the issuing party. Whatever is the verifiable piece of data associated with that credential can be proven within a ZK context and then sent on-chain, where then an external verifier can verify that, yes, this is someone who has this credential. The pro to this, obviously, is complete privacy preservation. The downside is it's actually quite hard. There's ways to approach this with various trade-offs, but one of the constraints that we have that's really specific to the world ecosystem is operating within really constrained consumer hardware devices. Like sometimes, within some parts of the world, people don't have like the flagship iOS or Android devices. So for this to be an inclusive system, we need this to run in kind of like the worst case with the constraints of 200 megabytes of memory, 10 megabytes of storage space, and about a 1-minute runtime before you start to run into issues with the OS, starting to try to kill processes that you're running on that device. It starts to get hairy at that point. And so, we have this set of constraints that we see as like, this is the bar, this is what we need to clear. And so our solution is essentially using Noir as a ZK front end, a custom proving backend to bring all of these things to the client side. And then after we generate a set of smaller proofs, they're sent to a server that runs this recursive Groth16 proof, where then that final proof can be sent on chain. So a quick look at this. On the client side, we're developing Noir implementations to firstly verify that an identity is like a valid identity. For example, a passport is signed by the correct issuing authority, that it contains the correct metadata that corresponds with the cryptographic commitment within that credential. And then further, a Noir implementation that allows us to compute over various predicates with that metadata associated with that credential. So for example, what is the age of that individual? What country are they from? And then with these, we're able to take the intermediate representation generated by Noir and then transform that into a GR1CS instance or a set of them, and then feed this into a Spartan sum check prover. And so this kind of comprises our custom proving backend, and this reduces everything into one polynomial evaluation over the GR1CS instance vector, which contains all the public inputs, the public outputs, the hidden inputs, and then the intermediate data from the actual circuit as well. And so then this set of proofs is sent to the server side, where we have a larger instance that can take all of the legwork and the compute and run this recursive Groth16 proof outer prover that uses a skyscraper hash function that basically compresses everything and then gives you one clean Groth16 proof to put on chain. And the reason why we use Groth16 is to optimize for proof size. It's 8 field elements, which translates to 8 words on the EVM. And then with some fancy math that Remco wrote a blog post about, we can compress it even further down to 4 words. And the reason that this is important is any layer 2 that's posting to a DA layer essentially is going to be competing for a blob space. So not only are you going to be paying more money to actually post this data on chain and eventually post it to DA later, but you're also making the blob availability a bit more contentious. So by keeping the actual proof size as small as possible, you're making things a bit more scalable within a layer 2 context. Some of the benefits on the client side, using a Noir front end gives us the ability to work within Rust-like syntax. This is huge. No longer does someone really have to have deep understandings of something like NoirCon, and they're able to, with a more friendly programming language, start to grapple with building these programs. It also allows us to support a wide range of operations quite easily and iterate quickly. This is something that we've had a really nice developer experience with so far. And then in terms of the actual backend, proving backend, we're using a Spartan interprover with a word evaluation proof that just gives us basically a maximally efficient proving backend for our use case. It also allows us to use to have like zero knowledge to preserve user privacy. And then lastly, some of the big benefits of using a recursive prover on the server side, it takes the compute off of the client. And so because we want to have this be, a flexible, extensible, accessible proving system, being able to have the user generate smaller proofs on their device and then send them to the server allows us to preserve privacy and then offload the compute to a larger instance. So some high-level advantage of this, there's no downloading, massive common reference strings, Spartan, and where it doesn't require a trusted setup. It's quite efficient and allows mobile devices to do this work client-side under the constraints that we're trying to optimize for, and then it retains complete zero knowledge. And then Noir just gives us like massive flexibility as we are developing, iterating, and thinking about like what sort of credentials can we use, what sort of predicates can we assert over this data, and really just quite a nice developer experience. So the roadmap moving forward, the core concept to really nail home is World operates on the principle of never storing any personal user data, biometric or otherwise, and the client-side proving needs to also adhere to these constraints. So that means it either needs to transmit 0 user data or attain statistical zero knowledge. So a ton of work is going into adding zero knowledge to the Spartan interprover, including the word evaluation proof. And then this also is the case for the Noir programs that are asserting that a given credential is a valid credential coming from a government, coming from really anything that's a verifiable credential. We hold ourselves to these standards today with the sign-up data that already is used in the sign-up and verification process. We use a Hyrax polynomial signature scheme. It's all open sourced. We've got a ton of data that you can take a peek at, papers, all of this kind of stuff. And then the AMPC check, as I mentioned as well, is all open source, papers published. Happy to chat about those details also. So at the moment, the World Network is one of the most privacy-preserving networks, and we're super excited about using Noir and seeing, how can we really push the bleeding edge of client-side proving, as well as opening up the possibilities that, World ID can bring to the world. So that's it. thanks for taking the time to listen. Typically, the applied research team is with us. So if there's any really low-level technical details on the proving back end, I'll be happy to defer some of those questions to them and get back to you on that. Otherwise, happy to take questions. And thanks.
Amazing. Thank you so much. If there are questions, please raise your hand. Awesome. Bring the mic over. If you don't mind just keeping your question on the briefer side so we can get to more. Thanks.
I'll try. Thank you. Really, really cool work you guys are doing. Amazing stuff. Really impressive. I had a question about this biometric stuff. So you use a biometric to register into a semaphore, and then you get a secret key, right? And so if you lose the secret key, you have to re-register. But you could lie, and then you could get 2 identities for free into that semaphore. So how do you deal with this problem?
Yeah, not quite. So 2 things to clarify. One is when you download the World app, you generate a semaphore key pair. So you don't actually have to come to the orb. It doesn't know your private key. Like, you are essentially just giving the public key to the semaphore key pair set that you already have generated on your phone to the orb to then insert on-chain into the Merkle tree. But the second thing is the actual software and hardware that the orb employs is doing exactly what you're mentioning. It's thwarting against, or it's its job is to stop that. So if a user comes and tries to sign up again, it'll again take that high resolution photo, capture the entropy in the eye, create that the byte array that is compressed, filters, iris code, encrypted, and then it's sent out to the AMPC check. That AMPC check is the actual logic that's ensuring that a user is not has not been seen before. This is a unique user. So again, happy to send you a ton of really cool papers I think you'd love to read if you're interested in the topic that dive really deeply into how that AMPC check works. So there's no duplicate identities that can happen there.
Okay, next question.
Hello. I've got a question about the collection of the iris data. Between when it collects it and when it goes to on-chain, have you had anyone come and try and interact with it and take it, like any attacks, basically?
Yeah, to be very clear, there's no biometric data that goes anywhere near the chain. The public key for the semaphore key pair set is the only thing that goes from the orb to and hits the chain, right? So that iris code that's derived from the entropy in the eye, encrypted, goes to the AMPC. It's a multi-party computation check to do the uniqueness check. And so, again, I'll kind of defer to, I'll send you all the papers, happy to go into the details there, but I know we're kind of short on time.
Yeah, that's good. Thank you.
Okay, any other questions? Please, yeah, get your hand up, and we still have a minute for maybe 1 or 2 more. Okay.
Thanks. I was wondering if you had any plans for a turnstile or some other recovery for any of the public whitelists.
Yeah, I can't speak on, I guess, the roadmap in terms of recovery. There's nothing that is different from what we've already kind of talked about and is published in our roadmap. But happy to chat further about some of the ideas you might have and stay in touch there.
Okay, thank you so much. I think
Thanks,
we're
everyone.
good at time. And yeah, just another round of applause. Daniel, thank you so much. Really cool work.